following presentation is meant for demonstrational purposes only. The material in this presentation has not been adapted from any coursework, curriculum, or textbook. All rights reserved for Prestige Academy. Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillahir Rahmanir Rahim. Welcome to Earth and Space Science Lesson 10. Today our lesson will be about solar eclipses. You've probably seen a solar eclipse before, or maybe you've seen a photo or video of one, but what is a solar eclipse? A solar eclipse is the phenomena of the moon passing between the sun and the earth, so that the view of the sun is obscured or blocked by the moon. If you go ahead and look at this diagram on the right, it illustrates this very nicely. You have the sun, and you have the earth. And now the moon orbits the earth in this fashion. And when it's right in the middle between the sun and the earth, there's the possibility of a solar eclipse occurring, because the light of the sun is blocked by the moon, which causes a shadow to fall upon the earth. This is known as an eclipse. This is a photo of an eclipse. This black disk here is actually the disk of the moon, blocking the disk of the sun. And this glowing halo of light around the disk of the moon is actually light or rays from the sun that we can see that are coming around the disk of the moon. 3 essential elements are needed for a solar eclipse to take place. Let's talk about each one of these elements individually, but let's review them here. Firstly, the sun and the moon need to appear to be the same size. Secondly, the moon has to be in a particular phase, known as old moon phase. And thirdly, the earth, moon, and sun need to line up in their orbits. Let's go ahead and take a look at element number 1. The sun and the moon need to appear to be the same size. Well, having this element present is easy because this is actually always the case. The sun and the moon always appear to be the same size from the earth. But why is this the case when we know in fact that the sun is much larger than the moon? Well, because of course the sun is farther away, but why do they look exactly the same size? Let's take a look at this diagram which illustrates this fact. The sun is 400 times larger than the moon. So if they were side by side, we would easily see the sun is much larger, in fact 400 times larger than the moon. But the sun is also 400 times farther away than the moon, and we know that as an object gets farther away, it appears smaller than its actual size. Because the number 400 is the ratio in both cases, the sun and the moon appear to be the same size. Had it been 400 to 300 or 500 to 100, either the sun would look larger than the moon or the moon would look larger than the sun. Let's take a look at an illustration. Here's us. Here's object number 1 and object number 2. Object number 1 is 3 times larger than object number 2. We would see that easily if they were side by side. But now if we move object number 1 twice as far away than its original position, it looks twice as small, meaning that it's now only 2 times larger looking than object number 2. If we were to move it 3 times farther away, it would look the same size. It looks 3 times smaller than its actual size. Because its actual size was 3 times larger than object number 2, but we moved it 3 times farther away, it becomes the same size, or looks the same size as object number 2. So because the sun is 400 times larger than the moon, but we move it 400 times farther away, for each unit of measure that we move it away, it appears a unit of measure smaller. So it was 400 times larger, but it's 400 times farther away. 400 to 400, so it looks exactly the same size as the moon. Here's a Kodak moment here to illustrate this point. We have on the right the moon, and we have on the left the sun. Both the moon and the sun appear to be exactly the same size from Earth. Wow. Let's take a moment of reflection. Isn't it amazing that Allah has created these 2 ratios, distance and diameter or size, exactly proportionate? Meaning, isn't it amazing that it's 400 in both cases? Scientists refer to this as an amazing coincidence or a fluke, because the probability that such a thing would happen when left to chance is so small. This phenomenon occurs nowhere else in our solar system. This means that Allah created this perfectly. This is a sign of His existence and a sign that He is the creator of the universe. Because it's so perfect, if it was left to chance, it would never happen. And also, it occurs nowhere else in our solar system. And we know that there isn't life on any other planet in our solar system, meaning that this phenomenon is put here for us, for this planet where jinn and mankind live, so that we can look and see and reflect on His signs. Also, what would happen if the ratios were not the same? The sun and the moon would never be able to overlap perfectly, meaning the sun would still look larger than the moon, or the moon would look larger than the sun, which would cause a frightening degree of darkness to take over the planet when an eclipse would occur. Their disk would never be able to overlap perfectly if the ratios 400 were not present in both cases. Pretty amazing. Let's take a look at essential element number 2. The moon has to be an old moon phase. What does that mean, old moon phase? Old moon is the final phase of the lunar cycle. Now, as Muslims, we're already kind of familiar with this concept of a lunar cycle. We know it has to do with Ramadan. When does Ramadan start? When does Ramadan end? But what exactly is the lunar cycle? Well, anybody who's alive can look in the night sky and see that the moon looks different on each day of the month. The beginning of the month, it's a crescent, then it gets larger and larger. You can look at this diagram here on the bottom. It becomes a quarter moon, then a half moon, then a full moon, then it goes back to being a 3/4 full moon, then back to a half moon, to a quarter moon, then back to a crescent again, and then finally, on the last day of the month, you can't see the moon at all. The moon becomes an old moon after it has completed all the previous stages, and you can't see it in the night sky at all from Earth. Let's take a moment of reflection here. Scientists often refer to old moon as new moon, meaning they consider it to be the first stage in the lunar cycle rather than the last. But this isn't accurate to consider it to be the first stage and to call it a new moon. Why? Because in the Islamic calendar, which keeps count of the days by the moon, the old moon phase is considered the last day of the month, and the new crescent that appears after the old moon is considered the new moon or the first day of the next month. It makes a lot more sense when you start a new month to start it by seeing a new thing. I mean, imagine if you considered the old moon the first day of the month. What if the sky was cloudy? You wouldn't know if it was there or not. Maybe the crescent was there and you just didn't see it. It makes a lot more sense to keep count by considering the first day of the month to be the appearance of the new crescent moon. During Sha'ban, the month before Ramadan, the day when the moon is in old moon phase is still considered part of Sha'ban, and fasting cannot commence until the new moon, or crescent signifying the first day of Ramadan, appears, or until we've counted 30 days of Sha'ban, which means if the situation is doubtful, we know, we can't see the moon, it's cloudy, or the moon might be in old moon phase, that's why we can't see it, we don't really know. We consider it the day of doubt, meaning we extend Sha'ban one more day, and then we start fasting the next day after we've completed 30 days or when we see the new crescent moon. Why is old moon needed for an eclipse? During the old moon phase, the illuminated part of the moon is facing away from the Earth, meaning it's facing the sun. In other words, the dark side of the moon is facing the Earth. Now here in this diagram, they've labeled it as new moon, but of course we're calling it old moon. The sun is over here in this region, or of course much farther away than the red arrow, but it's over here on this side. And these yellow arrows signify the rays of the sun. The rays of the sun are shining toward the Earth, as they always do, but the moon is right in between the sun and the Earth. And as the rays are shining, the side facing the sun is illuminated, and this side is in darkness, which is why, from our perspective, when we look toward the moon, we don't see anything. We just see darkness. Let's talk about the third element. Earth, moon, and sun line up in their orbits. Sun, moon, and Earth need to line up in their orbits for an eclipse to take place. That's pretty self-explanatory. If the moon is up here, or here, or here, an eclipse can't happen because this dark disk needs to completely cover the sun, or at least partially cover it, for an eclipse to take place. It won't cover the sun if it's not up in line with it. And here on this diagram you can see, here's the sun, here's the moon, here's the illuminated side which we just spoke about facing the sun, and that dark disk facing the Earth. It has to be in line with it to block it from our perspective. If it's up here or down here or over here, it won't obstruct the view of the sun from the Earth. Let's talk about this shadowy region here, the umbra and the penumbra. The first one, the umbra, is the shadowy region from which the point of light of the sun is completely obscured, meaning people standing in this region, the penumbra, will see a total solar eclipse. They will see the black disk of the moon completely eclipse or cover the sun. Now in the penumbra, the shadowy region from which the point of light is partially obscured, people see a partial solar eclipse. Meaning there's still some shadowiness, there's still some darkness, but that dark disk of the moon is only partially covering the sun. Now here we go. Let's say you're anticipating a solar eclipse. If you were to look at it, you would first be in the region known as the penumbra. Now this black disk is the moon that's coming and it's covering the sun. And then when it completely eclipses the sun, known as totality, you're now standing underneath what's called the umbra. It's darker. The disk of the sun is totally eclipsed by the disk of the moon. And then as the moon begins to move away again, starting over here, sorry, it keeps